Okay, so in this video we'll do more Yara rules, but this time I want to do a little bit differently. So I highly recommend you download this tool, which is a really hacker's multi-tool, like the developer said here. So get this tool, okay? Serboro suite. You have a full trial version, so you can check it out. If you like it, you can probably purchase it later. And the good thing about this, it not only has a disassembler, it also has a decompiler. Let's see how we can benefit from that. So I already installed this. Okay, all we need to do is right click here and then say Serboro Analyzer, and the installation, by the way, is very simple. Just next, and you're done. So we can see here we have the MZ header and we have the 4D5A. So this time actually what I'm going to do, I'm going to use the unsigned integer and 16 and say at offset 0 I want to find 0x, which is 5A 4D. Don't forget this is in Little Endian. So let's go to where Yara is actually. So lab 3, where is our Yara? Okay. So CMD here, let's open this, and now Yara -R, the rule number 6. Okay, and then we want to scan the user, and then the downloads directory. So every executable should be now, everyone that has an MZ header at the beginning, we will get the answer in here. So we have all of these are EXEs based on the PE file header for them. So that's part one. In this, I wanted to show how we can use an unsigned integer to do that. Now another thing is probably, let's see here, what do we have? So section headers. Okay, so let's assume we want to search for VC++. So let's do another rule. This one is not sys internals anyway, but this was actually for PE files. We can say that. So let's save that. But now let's do another. I want to do another rule, and I'm gonna call it number 7. Okay, but this time what I want to do is, so I want to search for this. That's definitely sure, and I also want to search in the sections for the VC++. So what I'm going to do is for, okay, any I in 0 PE dot number of sections. So we can do that. And now what I'm going to do is the search, what we want to search for, PE dot sections. We have I as the counter, so we want to cycle through I dot name because we're searching for the name. We don't want to do the same mistake we did in the previous video. And then we want to search for dot VC++. So this could be done like this. So now we should be able to find only this sample. Please don't tell me we have some errors in here. Oh, I did. I run the rule number 6. We want number 7. So this one should, let's give it another name. Beware me. That's what it was. And yep, we can find it. So it told me that the rule that identified this sample was called beware me. Okay, that's the name of our rule. That's what we gave it, and we can see it only identified this one. So we cycled through the sections, and we searched for this one exactly. Okay, so that's another way how you can, for example, cycle through a set of rules. Okay, let's do probably one more thing before I go to the really funny one, or not the funny one, I mean, but the one where we do check the code itself. So here what I want to do is probably check based on the PE sections. So I'm gonna use So the sections here, can we check them? Oh, great. So we can see here these sections. Good. So what else do we have? Anti-headers, file header. Yep, this one. Let's see. What do we have? File is executable, file is DLL. Okay, so let's do, this one is number 8. So what we want to do now is, let's do this type of check. So let's do and, okay, and let's do this time I'm gonna do for an imports, but I will see what I will search for. So I'm just gonna keep this empty for now and get back to it. And this is an and then here, let me do the let's make sure this is not a DLL. So we can do pe dot characteristics, okay, and we'll have an and between it, pe.dll. Okay, so let's do this, p characteristics and p.dll. So this one is not a DLL, so it should get us this one back. So let me just do continue trial. It's a trial version at the end. Optional sections, import directory, kernel 32. We have, let's take something. Yep, let's take this one. So can we copy the, yes, you see, so we can do, okay, we managed to copy that, and this was the mpr.dll. Okay, so we want all of this condition to work in order to identify our sample. This is number 8. So let's change that. Please don't tell me there is an error. It didn't work. So what did we do wrong in our case? PE correct. Oh, sorry. So I wanted to show you the not part. So now if we do that, yep. So we found out that we can also use the characteristics and the section. There's an and between them. Okay, so, and we said we don't want this to be part of what our search. So if I add one more thing, I know made things maybe a little bit more complicated. Let's add the one final thing. So I'm gonna add here something else. We don't have an and here, but this time if I go back to where is it, the optional file header, and I want to search for executable. Yeah, let's check for this one. So we can, and by the way, all of this documentation is on the Yara's documentation website. So here we're gonna do executable image. Let's see if this works now. It should also give. So we can, as you can see, we searched if this is an executable. Okay, and it's not a DLL and it has this function. So this makes our search much more precise if we are searching for a very specific sample on another system, for example. So let's do rule number 9, which is the one I will be using some of the good features of Serboro. I hope that's what it is called. So if I go to native code, as you can see now, we can look at the native code or the assembly of it, and we can see also here the byte code. I'm not sure how we can change here because there's probably more bytes than this. So let's see, probably in this free version we can't do that. I'm not sure about that yet. Let's see settings. maximum operation, max opcode. So this is 5. Let's put it 12 maybe. Yeah. Okay, so we can see more here. Yeah, and we don't have that plus. So I assume that these are actually the byte codes that we are searching for. So this is the entry point of the function of this program. So I just wanted to show you how we could probably use this. So let's say we know that this part is something from the sample, which will be very specific to this sample. So what we could do is use these byte codes to search for them. How are we going to do that? I'm going to show you in a little bit. But before I do that, one thing is if we press tab, so if we press tab, right? Where is it? The decompile. I did press tab. Okay, so maybe it wasn't able to decompile this. Tab decompile. It seems it's not able to decompile. Or do I have to select that? Tab. It seems it's not able to decompile it. We'll check that later. We don't need it now. For us, we need these. We need these bytes. So let's say we search for these bytes. Okay, let's search. Say we search for these bytes. So okay, let's see. Let's copy these. Okay. So what we can do here now in the string section. Okay. We can say. Let's say. VCC code equals, open the curly brackets, close it, and then add these bytes. So where is this? So you can see 6C, 6C twice. We can also, there are lots of other ways to tune this, but I'm gonna do this for now because I just want to learn the idea. So we can check that. Okay, let's see what else. We don't have anything over here. Let's assume this is very unique to our sample. So we have 6F, and then let me copy these, and then 6F, 6.3. Let me just bring this over here. So we have, after the 6C, we have 6F, and then we have 6.3.0.0, and then we have this. Okay. Yeah, let's do that now. So we are going to comment all of these out. And now what we are going to do is say we want the VCC or the V code. If we find the V code, then this is what our sample is, minus R rule. This is roll number 9, and then C users 1 downloads, and let's search. Okay, so we didn't find that. What is wrong with our rule? Let me check. So let me actually just add this and this, but I'm sure this is not the problem. So 69, 72, those were, did I by mistake added some bytes here? So we have 69, those were correct. 41, then we have 6C, 6C, 6F. I'm just worried about, because I do know, see, I'm worried about this. Not sure if this is the case. I don't remember if this will be. So see again, let's do the search now. Oh, no. So it doesn't really matter if it's uppercase or lowercase. Let me just check the documentation again. Okay, by the way, I just noticed the mistake I was doing. It was I was scanning the documents directory, which is empty. So if we scan the downloads, it will work. So let me just update the code again and show you what's gonna happen. So where were we here? This is the entry point, and I think we chose this code. So over here we had 6C, 6C, and then we had 6F, 6300, and then we had 56, and then we had this. Copy. So let's do that, and now let's do the search. So see, this time we managed to also find the sample, but let's say we managed to find the sample but using the byte codes of that sample. So what does this mean really? This means, by the way, if you have a sample from the same family, okay, so if let's say let me see if I have a hex editor over here. So we do have a hex editor, and let's make a copy of this but do some changes. So save file, gonna call it number 2. Okay, so what we want to do is, I just want to show you an example. So we were searching for these bytes. Let's see if I can do that here. I should be, but this is ASCII. Okay, can't we search for hex? No. Okay, so how are we gonna do that? Let's see, search bytes. Yep, this is the one. So maybe we need to, I haven't done this in this tool. Okay, so we did reach. So we have 75, then 61, 6C, 4, 6C, then we have, let's just search for all of this actually. Let me just search, since we can do that. Search for bytes. Hey, just do this for me, please. This was 74, 61, 6. And let's search. Okay, so let's probably go back to the beginning and do the search again. Search reached the end. Why is that? Did I delete a byte by mistake? What if we do search reached the end? How did that happen? Okay, at least give me these. Search bytes 69. Okay, now search reached the end again. That's crazy. To explain the idea, I can do something else, but I just wanted to show. Oh, I know why. Probably this is searching only for. Let me get the values from here. So wait. We'll get a solution. Here, let's get this, and now now go to our hex editor, edit, and then do, it's probably case sensitive. Okay, yeah, I think it's case sensitive. Okay, so we do have again 6F 6972 74 75 616 C 6C, and then we should have after that the 41. Oh, okay, so let's go back into this one, see what do we have here. 6C, okay, 6F. So let's just update our search. Let's minimize this a little bit so we can, instead of keep jumping around, we can now. So we have 41. Okay, we found that, and then after it we have the 6C, then 6F, then 6300, then 56, and then we have 69, the continue trial. We have the 6972 74 75 616C for us. Okay, so we did find this one. So this is the one that we found. So let's assume, I just wanted to show you this. So let's assume this is a 0, and this is 3, and this is 3, and this is probably 88. I just want to do one single these changes, show you what's going to happen. So now if we want to identify this sample, okay, we have these bytes which are what different from the other sample. So if we open the other one, okay, and we go, what offset was this? 36870. 36870. So if we, can we go to offset? Yeah. Continue trial. 36870, sorry. So go to offset. So this is 36, okay, 780. Wow. I really need some. This is 870, sorry. Okay, so we are here. So we have in our bytes, so if I go back here, let me do this rule number 10 and show you what will happen. So how will I identify both of those? And there is a slight difference in the bytes. Okay, so this one is 69, etc. But the other one, it's similar. Everything is similar except these. So what you will do is you'll put a question mark in this one, and this one is also different. So the 7 is the same, but the other one is 7 is the same, but the other digit is different. And then so 7 question, and then the other one, this, we add just 2 double question marks. Now if we search and do Yara -R rule number 10, 10, see users, user downloads, and now we should error scanning users. Oh, because they are both open, sorry. Okay, yeah. No rules, none of them match. Are you sure? So why is that? Let's see again. Hex editor. And if we go to the offset, this time I am gonna go correctly. So we go here, we had 6.9 here, it's then we have 7.3, so this is 7.3, 7.3 again, and then we have so we have 7.3, which is this, 7.3, which is this, and then we have the double question marks, then 616C. Oh, okay. I think I changed the yep, I don't know, my mistake. So what we are missing here is 616C, and then 616C, then we have the 41. Where did that go? Did I delete it by mistake? Let's see. Okay. Again, not found. Let's see this again. And if we go to offset, so this one is, why don't I just copy the bytes from here and that's it? So let me do this. Let me just copy these bytes from here, copy them hex, okay, and for now I'm just gonna comment this out and do $VC code, open close brackets, just add them over there. Okay, do I need these? Should be enough. Let's just go with this, see what happens now. Okay, continue. So we did find that. So now let's go to do the same thing but change just a couple of bytes in the other one. So if we go to the offset, that one, and now we have, so we change the 0, 73, that's different, 73, that's also different, and then we have 88, which is the double question marks, then 616C, then 41, 6C, 41, then 6C, 6C again. Okay, so this is probably where our mistake was. So 6C, then 6F, 6300, 5669, and then the 7274, 7561, 6C, and then 46. Yeah, this one should work now. This is not, by the way, we'll usually use it, but I just wanted to show you how you can use the search for bytes instead of searching for just strings. See, now we can find, now we managed to find, I think we had 1 byte missing there. So if we have only 1 byte missing, we can replace it with this. If we have, we can that. If we have the whole 1 nibble, sorry, we can replace it this way. If we have a whole byte, we can replace it that way. So what does this help? How does this help you? So let's say this is a function. This is a function in a malware sample, and it's unique to, let's say, a specific malware family. You can use this code to search for it. Okay, you can use this search code to search for it and write a malware, a Yara rule for that to search for exactly this code. Okay, so I hope now you have a good amount of information about how to write Yara rules. I think I covered most of the let's say approaches that you will need, or I wrote a lot of examples, I mean. So I hope this will be useful to you. If you have any questions, feel free to ask. That's it, and see you in another video. Bye bye.